Hey there, geometry. Let's just start that over. Hey there, geometry students. Mr. Rising here once again. In this short lecture, I want to talk to you about your Theodolite performance assessment, specifically how to build it and how to use it. So this tool right here is called a Theodolite. It's a way to accurately measure angles. This has been used in surveying, in stargazing, a number of things. It's a very precise tool. What you're going to do is you're actually going to build a tool that's not as precise, but it still works. And here's the whole point of basically how it works and what's the big point. If you have an object, such as a tree, that you're trying to measure the height of, you can stand there. Now, imagine I'm there, right? So my little theodolite, it's in the air, it's not on the ground, right? Because I have to hold it up. So you hold up your theodolite, and basically you can look from your theodolite to the top of the object. You can record your distance from where you're standing to the object, and that will help you determine the height of the object, like so. Again, one of the reasons this works is we know that things that are vertical are perpendicular. So basically what we've done is we've made a right triangle. And now we can use trigonometry to say, oh, wait a minute. If I know this angle's 90, I know this is how far I am away from the object, and I can figure out this angle. I can use that trig to determine all the other sides and angles in that triangle. So that's the big idea. How to make a theodolite? Well, first of all, you need a protractor. If you don't have a protractor, you're going to build one. Take a circle, fold it in half, right? And then mark your 90, your zeros, and basically estimate your marks. Hopefully all of you have a protractor. And if you need one, make sure you email me. I can try to get one to you before the next time we meet. When I originally did this assignment, what I was doing was, having you tie a loop in the string and put on a sight, and I realized, wait a minute, it is way simpler than that. But you do need a paper clip. So I found a paper clip, and I opened it up. And you probably can't even see that. There we go. Now you can see a paper clip, right? And I bent it, and watch what I'm going to do. I'm just going to feed that right through my protractor, and if I hold my protractor level, right, it just hangs straight down. Pretty cool, right? That's pretty cool. All right. And again, there was a straw. You can use a straw as a wrap because basically you're making an eye sight. And then you can attach the straw to the top. By the way, on my phone, I have a theodolite. It's called a clinometer, and I'll just open that up here on the side just to show you. But here's how it works. Number one, it's better if you have a helper. If you don't have a helper, that's okay. Don't worry about it. You can actually do this by yourself. So what you're going to do, you go outside, you find an object, and you're going to record your distance from the object. Now notice your eye is the same distance from the object as your feet. Clever, right? Now if you don't have a measuring tape, pace it out. Every 2 steps is 1 pace. And roughly, if you're between 5 and 6 feet tall, your pace, 1 pace is 5 feet. So every 2 steps is 5 feet. So take 5 paces from an object, you're 25 feet from that object, right? Be more accurate, right, and you'll get a better result. So you figure out your distance, AC, from the object, and then one of you is going to sight. Now, if you can't quite see this because of the background, I'll use a blocker. There you go. Is that a blocker? I don't know. Does that make it better? Anyway, what you're going to do, you're going to look up. Now, I'm working in Studio Seward High School, room 105, and I'm looking at somebody's, whatever that is. Looks like it's a hexagonal pyramid, right? And I lined it up just perfectly, and then once it stops shaking, I can grab it. It also works well if somebody else grabs it for you, right? They can actually read it for you. All right, so one cites it, the other reads. If you're all by yourself, well, then you're going to cite and read it yourself. Once you figure out that angle, well, I'm going to hold it up right here. It says, dun-dun, 50 degrees. You're going to plug the reading as 50 and do the absolute value. You're going to do 90 minus the reading to determine your angle. So if you set on your protractor that it's 50, it's actually 40. Because look, straight down is 90. Well, that's not 90, it's level, it's 0. 90 minus 90 is 0, right? You tilt it up a little ways, right? It's going to hang down. You tilt it up really steep, it's going to say 10 degrees. Well, that's not a 10-degree angle, right? If it records 10 degrees, it's actually an 80-degree angle. So that's really important. I think that's where a lot of students have confusion over the years. So again, whatever your reading is, subtract your reading from 90 and take the absolute value. No negative angles, nothing like that. Some of you might say, well, I recorded it, it's at 120 degrees. Well, 90 minus 120 is negative 30. The absolute value of negative 30 is positive 30. That means this angle right here is 30 degrees. Oh my gosh, I'm running long. Now, perform trig to calculate BC. So for those of you, here, I'm just going to use a sticky. You guys love sticky notes, right? If I'm standing at A and I want to know BC, well, BC is the opposite side, right? And I know the adjacent side. So opposite over adjacent is tangent. Okay, so the tangent, I said my angle was actually 40 degrees. The reading was 50, but 90 minus 50 is 40, equals, and let's say I was standing 25 feet away from the object. It would look something like that. Now, with a little bit of algebra, multiply both sides by 25. Ta-da! And then on my trusty calculator, I do 25 times the tangent of 40. Like that. Hit enter, and bam. 20.977. We're going to call that 21 feet. So B to C is 21 feet. Let me just drop in a quick little box here. BC equals 21 feet. Now, that's not the height of the flagpole. That's the height from the top of the flagpole to my eye level. And again, I'm 5'8", but my eyes are probably about 5 foot. So I'm going to add my eye height, or my entire height, to it. And then I would say, oh yeah, the flagpole is 26 feet tall. I hope that helps, because you definitely have to know how to do this in order to do the performance task.